Hello, hello. This is Virtual Reinhardt coming out to you, my distance learners. I wanted to walk you through Unit 1, primitive variables, primitive types in some more detail. I'm not going to go quite in the same order that we do in the book, all right? But I do want to hit just about every topic a little bit, as well as a couple of new ones, completely new ones. But some of this is review, but there's a lot of new stuff, special cases and things, so pay close attention. I am going to go relatively fast, so remember to stop it, rewind it, watch it again. But I'll let you be in control of that. All right, let's start. We started by figuring out what makes a Java program a program. You start with a header and a main method, and that's the text that you need to make that happen. You can see I have a lot of comments here. So comments are something I'm going to put in my code to explain what it is. All right. We talked about syntax errors. We talked about quotation marks, opening and closing curly brackets. Those things I'm not going to cover, but they are in this thing, in this program. All right. So you might notice the first two actual commands we did were print and println. The only difference is print will not add a new line following displaying the text to the screen. So in this case, these two lines right here, lines 3 and 4, would appear on the same line on the display because there's no print line right here. Okay, the println here affects any future print or println statements. They would appear underneath it. All right, moving on. We declared variables. I have declared 3 variables, 2 different types right here. Type int x, int y, double my shoe size. Notice these are not good variable names, x and y, because we don't know what kind of data it's holding. This is a much better variable name. Okay, and that's generally how you write variable names. It's called camel casing, lowercase to start it, then uppercase, and then uppercase. That is the best way to name a variable, descriptive and camel-cased. Separate your words with uppercase letters. So integers hold whole numbers and their negatives, no decimal points, okay? And you have to. Doubles hold decimals, okay? Now here's a slight kind of oddity with that. This is okay. You can put a 3 or any integer into a double variable because you're not going to lose any data. It does, however, my GPA in this case, this variable right here, is actually, if you printed it out, would be 3.0. Okay, the other side of that is this. You cannot do this. You cannot put 5.5 into an integer type variable. You'll get a syntax error. It won't compile. It won't run. All right. However, something you just read about, something brand new, you can cast it. So if I cast the 6.5, it actually eliminates the decimal and converts it to 6. Notice it does not round it. Casting it does not round it. So your brother who says he's 6.5, right? Okay, if you cast your brother's age into an integer like so, it would convert to 6. All right. Moving along, mathematical operators, no real big surprise here. I'm referencing variable names, and I have 2 plus 3 is 5. We saw this 2 minus 3 is -1. 2 times 3 is 6. This is the slight oddity with mathematical operations. When you have 2 integers, you will create an integer. So really what we're saying, 2 divided by 3, because that's the values of x and y, is 0 because 3 does not go into there. 0 3's into 2, and it does not include the decimal. So any numerator that's larger than the denominator will be 0. You can also test for equality. So remember, these values up top, that is not the equal sign. That means it gets that value. It's assigned to that value. If you want to test for equality, you use the double equal sign. So in this case, you're asking the computer, does 2 equal 3? And this will print out false because they are not equal. So you're asking it a question. This one, however, does 2 not equal 3? That's true. And that's exactly what would print out to the screen. false and true in this case, given the value of x and y. All right, moving along. We can also assign variables. Remember, I'm assigning a new variable called z, type int, to an equation. Doesn't mean necessarily anything here, just to show you what's happening. This will follow PEMDAS or PERMDAS, so multiplication will happen first, okay, before it adds. So that would happen, multiply 2 times x before it adds or subtracts, and then it goes left to right. More variables. The third type we talked about was type Boolean. Boolean is a true or a false. So generally those types of names are descriptive and camel case, just like the other one, and ask a question. Is it nice outside? True or false? And you just type in true or false, no quotes or anything. You can also, and this looks super strange, but a slight odd case, can you take this situation and use the equal sign, which is 2 equal sign, to assign a Boolean variable? You can. So this would actually, the value would be false, okay? Because does 2 equal 3? False. So the value of this variable would be false. All right. You could reassign variables as we've seen before. So I'm reassigning variable. Now I'm testing to see does 2 not equal 3, and now value would be assigned true. Line 26, I'm asking the computer is 2 greater than 3. That now then reassigns value back to false. All right. Next, modulo operator and integer division. You can do some cool things with this. Remember, this is a modulo. It's the remainder when dividing. So remainder when dividing. I'm going to say that again with a dramatic effect. Remainder when dividing. Okay, so what happens when you divide 738 by 10? You get a remainder of 8. Okay, what happens when you divide 2 by 4? You get a remainder of 2. It's 0, remainder 2. 884, remainder when you divide by 2 is 0. Okay, I'm showing what would print out to the screen here. And what's the remainder when I divide that odd number by 2? 1. All right, so what can you use with this? Actually, it's quite handy. In this case, what if you wanted a remainder calculator program? You could take some number, some other number, and then with integer division, you could divide them, and that would show you how many 33s go into 567. And the actual answer, I have it down here on the next page, it's 17. Okay, and then I'm going to print out to the screen an R. Notice it's not println. And then I'm going to take the same thing to determine a remainder, 567 mod 33, and that is 6. So this piece of text here would actually display that right there, 17R6. Actually, it would display this only. There's no display. Okay? Now, what if we wanted those two numbers to actually print out their decimal values? What could we do? Good question. Glad you asked. First of all, if either one of these variables up here was a double, it would divide with decimals. All right? But what if we don't want to do it that way? There's another option. You can cast it. I can get the decimal answer. Okay, so I'm just printing a label for some text and combining it or concatenating it with the answer. And this will then convert temporarily num1 to a decimal. So num1 was 567. Temporarily, just for this equation, it'll be 567.0 divided by 33. And then this will print out the actual decimal answer. Okay, 17 point something. All right, almost done. Now, some new notation for you. Now, you subtract and add 1 from variables a lot. You change variables by a little bit, a lot. Therefore, Java has ways to called compound operators. Those compound operators make it easier to write. So, for instance, this is a way to subtract 1 from num2. You could do it another way. You could do it this way. subtracts 1 from num2. Or you could do it this way, subtract 1 from num2. Okay? For the record, you can also do it this way, subtracts 1 from num2. Subtracts 1 from num2, that's the same thing. All right? You can put the minus sign on either side. All right? If you wanted to add something other than 1, you can just do it this way. Again, that's the same as writing that. All right? Quite often, actually, the most common thing that you'll see is something like num plus plus. Okay? You generally add 1 to a variable more than you'd subtract, so you'll see that a lot. In fact, a variable we use a lot in a loop is I. I plus plus is something that you'll see a lot, followed by a semicolon. I think that is it for Unit 1 content. So, like I said, rewatch this. It is 11 minutes well spent. You can get through the whole unit in 11 minutes. Just take your time. Good luck. Reach out if you have any questions. See you soon.